Okay, here we are. Last lesson of Unit 2. This is Unit 2, Lesson 7. We are all the way to the point of applying what we know about quadratic relations. So, word problems and quadratic relations. The biggest challenge you will have is reading the question, interpreting what it means. So, your job is going to be to look for basically 3 terms in a word problem. And those terms will then tell you what you need to do. The 3 terms are either maximum or minimum, initial position or initial value, and then the points where the y value is 0, which usually in a word problem is talking about hitting the ground or breaking even. So the first one, maximum, minimum, exactly what it sounds like. A maximum would be a high point and a minimum would be a low point. And we've already talked about these when we've graphed. A maximum or a minimum or a high or a low is the vertex. When you think about your parabola shape, the vertex is where it's the highest spot on the graph or the lowest spot. So we can get our maximum or minimum from the k value of the vertex. We can read it from the equation or from the graph. Initial position or initial value. Initial is just like it sounds. It means the start. To figure out the starting point on a quadratic, it is the y-intercept. You get the y-intercept just like you do with a line. You can read it off the graph, or if you don't have a graph, as sometimes is the case with quadratics, you can calculate it by substituting x equals 0 and calculating y. Last one. When you're reading a word problem and it talks about something hitting the ground or breaking even, this is where the y value is 0. These are special points called the x-intercepts. And x-intercepts are kind of the opposite of y-intercepts. The x-intercepts is where the parabola crosses the x-axis. So those are 3 key things you're going to look for in your word problem. Maximum or minimum is the vertex. Initial position or initial value is the y-intercept. And something hitting the ground or breaking even are the x-intercepts. So let's take a look at a few equations. So for the, excuse me. For the 4 equations below, determine the initial value of the parabola and the maximum or minimum if possible. So we talked about the initial value. The initial value is the y-intercept. And you can get it from looking at the graph and seeing where it crosses the y-axis. Obviously, with 4 equations, we don't have a graph. And we tend not to like to do more work than we have to, so let's not make a graph. So we can still find the initial value by putting 0 in for x. So let x equal 0. That's going to give me 0 plus 4 squared minus 15. And then I remember BEDMAS. Do my brackets first. So 4 squared minus 15, which would be 16 minus 15, or 1. So therefore, the initial value is 1. And I'm going to go through and do the initial value for each one of them. Same process every time, no matter what your equation looks like. So I'm going to take out x, and I'm going to put in 0. And I'm going to remember my BEDMAS. So brackets first, and then exponents and multiplication and adding. So my exponent would be next. Negative 1 squared is positive 1 times negative 2 would be negative 2 plus 12, which would be 10. Therefore, the initial value is 10. You'll notice that the second 2 equations look different than the first 2. Remember way back, they're still quadratics because they have an x squared. But the first 2 are in our usual vertex form. What we're used to seeing with graphing and getting information. These 2 are not in vertex form. When they're not in vertex form, we're still going to get the initial value the same way. Take out x and put in 0. And BEDMAS, 0 squared is 0. times 2 would still be 0. 5 times 0 would be 0. Take away 15. So we'd have negative 15. Therefore, initial value is negative 15. And the same thing with this one. Initial value, let x equal 0, and calculate. And when we calculate that all out, we end up with initial value of 12. You should have noticed something with these last two. Math is all about the patterns. Look at the last number in the equation and our initial value. The last number in the equation and our initial value. When the equation is written, x squared, x and a number at the end, that number at the end will always be your initial value. So that's the first part, the initial value. Second part is the maximum or the minimum if possible. The if possible is there because if the equation is not in vertex form, then you can't find the maximum or minimum right now. So because the last two are not in vertex form, you can't find the maximum or minimum without making a graph. So we're going to leave the last two. The maximum or minimum, let's look at the first two. To find the maximum or minimum, let's just write that down. It's easiest in vertex form because the vertex helps us get the maximum or minimum. The only other thing is we have to decide if it is a maximum, a high point, or a minimum, a low point. You'll know it's a maximum if it opens down because the vertex will be the highest point. And you'll know it's a minimum if it opens up. So think about your parabolas. I've run out of space. Maybe I'll squish it in here. If I have a graph, if I have a parabola that opens up or a parabola that opens down, the one that opens up has a low point, so it has a minimum. And the one that opens down has a high point, so it has a maximum. Then the question becomes, how do we know if it opens up or opens down? That is the good old A value from our equation. If the A value is positive, it'll open up. If the A value is negative, it'll open down. So I'm going to look at my first equation. My A value is positive 1. So it's going to open up. So it will have a minimum of whatever the vertex is. So I look at my equation. The vertex is -4 and -15. So the minimum of value of that equation is -15. I'm going to look at my second one now. My A value is negative, so it's going to open down. That means I will have a maximum value from my vertex. My vertex is 1 and 12. So the maximum value is 12. Easy peasy. Now we started this by talking about word problems. So let's actually look at a word problem. A model rocket is launched from the roof of a building. The flight path of the rocket through the air is modeled by the equation h equals -5 bracket t minus 3 bracket squared plus 55, where h is the height of the rocket in meters and t is the time since launch in seconds. And then we've got some questions to answer. First comment. Word problems very rarely use y and x. So don't get all worried about the different letters. Think about the pattern we know. Y equals a bracket x minus h squared plus k. So our h is like our y and our t is like our x. And our a and our h and our k are our vertical stretch or shrink and our vertex, just like always. How high is the building? Let's look at the question. A model rocket launched on the roof of a building. The flight path through the air is modeled by the equation where h is the height of the rocket in meters and t is the time since the launch. So we're talking about, we've got a building, and we've got the ground, and they're shooting the rocket off of the building. So the rocket is going to start and go up and land on the ground. So the rocket will start on the building. How high is the building? Therefore, is the start. Another word for start is initial. So we're looking for the initial value, which we just talked about. The initial value comes from the y-intercept, but we don't have a graph to look at to see where it crosses the y-axis, or setting x equals 0. There's no x, but we already talked about, that's okay, the t is the x. So we're going to put t equal to 0. So we've got -5 bracket 0 minus 3 squared plus 55. So -3 squared plus 55. Do some math here. -3 squared is 9 times -5 is -45 plus 55 would make that 10. So write me a little sentence. The height of the building is 10 meters. So far, so good. All right, next keyword, question B. What is the maximum height that the rocket will reach? So if I think about my rocket, it's going up, it's going down. Remember the maximum, as soon as you see that word, you're thinking vertex. So if I look at my equation, my vertex is 3 and 55. So I'm going over 3 and up 55. So because I've gone over 3 and up 55, the maximum height is the up. So the maximum height is 55 meters. That is as high as our rocket goes. How high will the rocket be 2 seconds after launch? So 2 seconds is a time. In our equation, we have a T that stands for time. So all it's asking us to do is take out the T and put in not a 5. There we go. Put it in a 2. So we've got -5 bracket 2 minus 3 squared plus 55, and use our equation to figure out h, which is the height. Do a little bed mass. -1 squared is 4 times -5. -1 squared is 4. What am I saying? -1 squared is 1 times -5 is -5. 55 is 50. Do my little statement. Therefore, after 2 seconds, the rocket is 50 meters. And last but not least, sketch a graph of the situation and label all relevant points. All right, so we've got our axis. We know that the rocket started at 10 meters high, which is the y-intercept, 10. We know that after 3, because of the vertex, so over 3 and up 55. 3 and 55 is our vertex. And we know that after 2 seconds, it was 50 meters. So 2 seconds, it was 50 meters. So we started here, we go up, and we come back down. And there's the path of our rocket. So everywhere problem is going to be different. You're going to need to figure out what the words mean. Look specifically for words like maximum, initial value, hitting the ground. Those are the 3 key ideas. So your job now is to practice looking for those key ideas and applying them. All right, good luck with that.